Hi, welcome back. So let's take a look at a few more examples here. The derivative natural log of x. Alright, so here we have kind of a problem where students can get really stuck. So in this case we have y equals the natural log of x quantity cubed versus the natural log of x itself being cubed. And what we're looking to find here is the derivatives. Now let's start with this one right here. This is just a chain rule. If I were to take the derivative, we should get 3 natural log of x squared times, what's the derivative of the inside? That's our chain rule, 1 over x, right? That's our chain rule. Over here, I can actually, if I wanted to, use my property here. I don't have to, but I could. This one said I can just drop my power. And I can write this as y equals 3 natural log of x. The derivative then being dy dx becomes 3 times 1 over x. The derivative natural log of x is 1 over x, right? And there's our answer there. Be careful, a lot of times students think they can use their property here. You really can't. Now, let's say you didn't want to use your property this one. I could just do my straightforward chain derivative here, chain rule. I get 1 over x cubed times the derivative of the inside, which is 3x squared, which becomes just, again, 3 over x. We can see that. So I can do this one a couple different ways, but here I can only do this one using chain rule. Alright, let's get tricky with it. Let's take a look at the natural log of the cosine of x. And if I want to find the derivative here, dy dx, my rule says we're going to get 1 over the cosine of x times, it's a chain rule, I have to do the derivative of the inside, and that becomes negative sine of x, which is, of course, negative tangent of x. Or what I like to say, do you want to do this problem? No tanks. Ha! I kill it every time. Moving on. Know thy properties. It's the 12th commandment, okay? It's the 12th commandment. Know thy properties. We want to take this derivative right here. Now, to get this derivative, we're definitely going to want to do the properties on this one, people. Okay? All right? Don't be a hero. We want to expand this. Okay? And I kind of did that right there with that little Drake meme. It's pretty dank. When I expand this, we're going to get y equals the natural log 4 plus x squared to the 1/2 minus the natural log of x. I'm using my property expansions right here. Now, depending on how good you are with expanding, I can do this in 1 step or 2 steps. Now I'm going to use my power expansion. Rewrite this. 1/2 the natural log 4 plus x squared minus the natural log of x. And at this moment, we realize, even though we had to do a little bit of algebra beforehand, man, if I didn't do it, I'd have to do a quotient rule with a chain rule on the inside. That's nasty. So now I'm ready to take the derivative. We're going to get this 1/2 times, what's the derivative of natural log? It's just 1 over this 4 plus x squared. Chain rule, the derivative of the inside, 2x. Minus the derivative of natural log of x, 1 over x. And there is our derivative. And now I know what you're all thinking. Mr. Wernow, I think these properties are pretty easy. I'm not having really a hard time doing them. But how is this going to help me with my tangent line? Oh, that's a really good question. Let's take a look at example number 11. We want to write the equation of the tangent line of this graph at this point. So when we write the equation of a tangent line, the first thing we need is a point, and we're given 1, negative 1. Next, we need the slope of the line. For that, we need the derivative. dy dx is the derivative 5 times 1 over x minus 3x squared. It's nice not being doing related rates right now, I know. So there's my derivative. But to get the slope, remember we need that little fancy notation here, dy dx at x equals 1. I only care about the point x equals 1. And if I plug it in, we're going to get 5 over 1 minus 3 times 1 squared, which is 2. So my tangent line, y plus 1 equal to 2, x minus 1. And there is our tangent line. Ta-da! All right. know what you're thinking. Yo, Mr. Wornow, can we do implicits with these? Absolutely we can. Ready? If I take the derivative here, we're going to get 3x squared plus the derivative of 2 natural log of y is 2 times 1 over y. But be careful, this is implicit. Because I'm taking the derivative of a y, I better multiply by my dy dx. Plus, this becomes, of course, 3y squared dy dx. And that's going to equal 0. Ta-da! There's my derivative. But remember, we have to solve for dy dx. So anything with the dy dx will stay. So I can write this as dy dx. And, And I can factor this out. This becomes 2 over y plus 3y squared. What is that going to equal? I'm going to bring everything else over, which is just at negative 3x squared. So therefore, I can say that my derivative dy dx is equal to negative 3x squared over 2 over y plus 3y squared. Now we're still not done because your eagle-eyed viewers out there recognize this has to be multiplied by y. We have an LCD here. So we're going to multiply top and bottom by our LCD, which is y. And if we did that, negative 3x squared y over, distribute, the y's cancel, we're left with 2 plus 3y cubed. And there's our derivative. Well, that's the end of our lesson. What I'm going to do for the next few minutes, though, is I'm going to work on solving a few of these exponential equations, because I know it's been a while since you've done them. So let's take a look at solving a few exponential equations, or log equations here. So let's say I am giving the following equations. Like, say, 5 equals natural log of x, and I want to solve for x. Well, I'm going to, that big word we talked about in my first video, I'm going to exponentiate. Exponentiation just means you're going to convert these to a base. You can convert these to a power, You're going to make them exponents. In this case, I'm going to use my base for log, which is e. E on both sides, because e to the natural log of x, is just 1. So what are we saying here? X is just going to be e to the 5th. Very easy to do. I can make these harder. Let's say I did this as 1.7 equals 5 natural log of x minus 3. Something crazy like this. Plus 1. Why not? I'm going to solve this. Whoop, plus 1. I'm going to bring this over. That's going to give me 0.7 equals 5 natural log x minus 3 divided by 5. 0.7 over 5 equals natural log of x minus 3. And now I'm going to exponentiate. E it. Like Michael Jackson said, just E it. Just E it. Ooh, I thought I never told you never come around here. Right, we're going to exponentiate. So this becomes e to the 0.7 over 5 equals, those cancel, x minus 3. So therefore, what's x going to equal? E to the 0.7 over 5 plus 3. And there's my answer right there. So exponentiation is a really, really good skill to have. We're going to be seeing it a lot this year. All right, I hope you enjoyed these videos, and I will see you next time. Thank you. Bye-bye.